Hello, hello. This is problem 2. I am going to make sure that I explain this very well doing this live because I actually didn't. So I submitted the code on LeetCode because I found the problem on Leet and it was accepted over there, but I didn't run through it as I'm explaining. So I'm going to be very careful in doing this now. So we are on problem 2, and we are going to try to remove all adjacent duplicates, and that's what this problem is called. Remove adjacent. Wait, that's not how you spell adjacent. Ha ha ha. Adjacent. I'm quite tired. Um, Duplicates. It's nighttime here, and I'm very, very sleepy. Removing adjacent duplicates. So the exact prompt says, just to remind myself, given a string. Okay, so yeah, we have a string. Let me write the example of our string. Input string. Probably should have said input string. Our input string. Given a string, recursively remove adjacent duplicate characters from string. The output string should not have any adjacent duplicates. See following examples. So, I don't know I know what recursively means. I just am not totally sure if this problem wants me to do it recursively, because it is an option to do it recursively. It's just not a good option. So I don't know if that's mandatory, or were we going to go with something that runs better that doesn't have to use recursion. So yeah, I'm not sure what, given a string, recursively remove adjacent, because there's a better way of doing it. So I can't tell if it's like we are definitely going to have to use for loop, but we don't need recursion for it. So because the recursion would make it, you have to go through each of everything in the string again and again and again. Whereas if we do it with the stack, we don't have to. So I'm gonna use the stack method. Yeah. So given the string, did I read the prompt? I don't remember. Given a string, remove adjacent duplicate characters from string. The output string should not have any adjacent duplicates. See following examples. So essentially, no output in the string should have duplicates right next to each other at all. They have to be completely removed. And that is why we need a stack for this, because the other method of iterating through and doing everything in line can't remove everything. It would leave there wouldn't be anything adjacent, but they will not remove all of any they're gonna remove it's they will remove everything but the last one, essentially. Um, which I guess does work. It's just not going to return the goal output that's written in the problem prompt. So I'm going to write the inputs and then write the output. So the string is A, Z, X, X, Z, Y. And the goal output we're looking for here, and this is actually a really short code, is A and Y. And so adjacent duplicate means whatever is the same, like if your direct neighbor is the same. So A is one guy and his neighbor is Z. A and Z are not the same, so they are not duplicates. But if we move to, and let's say we pick out X as our guy, well, X is X's neighbor. They are duplicates, so we need to kill off these guys. And the problem is, once we kill off these guys right here are going to be now adjacent duplicates. And that's not good because we got to remove these guys too, which in the end will turn into the output, which is A and Y, as they are unique non-duplicate string characters that are next to each other. So I think this is the example on LeetCode, but I'm just going to do another example. So let's say the input could also be A, B, B, A, C, A. Then what that means is, in the same sense, the output would be CA because this would need to go and these would need to go, which remains this and this. So hopefully that makes sense. That's my example. What we're trying to do here is just remove any duplicates right next door. And the tricky part of this, and I didn't think about it at first, the tricky part of this is, yes, you can remove the B's. That's fine. If they match, just kill it off. But then you're going to need to go back, which I guess what is where recursively means. But you got to go back and go, oh, but now these two A's that weren't touching before are now touching. So we got to get rid of these suckers. You know what I mean? Yeah, that's the trick. So I'm going to find a type right away to illustrate. I'm trying to illustrate it correctly because I know the code works, but I would like to see it in my mind as I'm writing. So I'm gonna write the code first, and then I'm gonna draw it as I go. I think this will help me because I want to see the stack in action. Since it's hard to visualize this kind of stuff. So I want to make sure if I'm gonna draw it out, I want to visualize every single action move it does, so I can fully understand it completely. So yeah, let's write a. So we're gonna write a function. So define. What do I call it? Remove adjacent. Why do I keep spelling adjacent with D? There's no D in adjacent. Oh wait, there is. Wait, is it? Oh my god, did I spell it wrong? No, it's ah I oh there is a D. Duh. Oh my god, I'm so dumb. Sorry, I don't know how to spell adjacent apparently. Adjacent. Wow, that's so embarrassing. I was like, there is a D in there actually. And then, but then I didn't write one with a D, and I realized that's where I made a mistake. Adjacent. There you go. Hey, at least I caught it. I was like, wait, that doesn't look right. So I know how to spell adjacent. I swear. I'm very tired. It's 10 p.m. tonight. I mean, it's 10 p.m. right now. I've been up since 6. So I would like to. Oh, sorry, that was my phone. What was I talking about? Oh yeah, we're writing a function that. Oh yeah, that's going to take an input. um. Um. Oh, I forgot to introduce my code. Okay. Yeah, and I'm just gonna write it. Sorry. I'm all over the place. Okay. So we're going to accept a string as an input. Because the string is right here. Cool, cool. I can't even draw a box. Okay. Cool, cool. And then we're gonna so the hint on the code was to use a stack, which kind of tells us the answer. Just use a stack. So here's the stack that I am going to illustrate. It is a magnificently beautiful stack full of good things. Okay, so let me just so we just drew a stack. Let me code out a new stack. And I'm gonna name it stack. And this is the empty stack, and this is basically this thing. Cool. Okay. And now we are going to. Wait a second. I need a burp. Okay, I'm back. So, sorry about that. So now we're going to write a for loop since we created a stack. I'm gonna write for so character is what I'm naming each well, character in the string, obviously. For character in string, we're gonna use stack if stack and stack -1 equals I ran out of room again. Dang it. How do I write character on such a small space? Dang it! Character. Oh dear God, that's embarrassing. I'm so sorry, guys. That says character. I wanted to do so much better than this, but I already ran out of space. No, I hate it. I'm just gonna write. I'm just gonna redo it because that bothers me. That bothers me so much. I'm so sorry. I'm gonna write small if stack and I'm just gonna do stack. This is somehow worse. At least I wrote it well the first time. Equals character. Then we're gonna pop it off stack. Stack. Oh, I keep pressing the stupid button on the pen. Pop the sucker. Else. Wow, it's so much easier to stack. Else, we're going to add it to the stack. Oh my God, what is wrong with my pen? It looks like I wrote stock instead of stack. Okay, else. Oh, it was going so well. What did I press? I swear. I think I pressed something. That was all psycho bananas on me again. Stack.append. I don't even know where I am. Appending character. Oh, good lord. And then we're going to return the string, a space, join it with the stack. And then, so basically we're going to return the stack. Okay, so, with a space in between. Okay. So, for this code, maybe I should explain it before. So this guy is this guy, the stack structure, and for character and string, so this guy is, we are starting here, and then we are going to take each character in the string. So beep, 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 beep. These are all individual characters in string. And what we're going to do is we're going to plop this first A into the stack, because this is what this line is saying. Oh wait, not this line, sorry. We skipped this one. We're skipping this one. We are doing this one. So that's what's going here. Oh my God, it's terrible. There's so many arrows. I'm trying a new way to explain, and I don't know if it's working. But yes, okay, and then we have Z. Z is pretty much the same thing because it skips this condition. So Z just gets plopped in like A did. Z. Oh my god. This is kind of embarrassing. There's so many arrows. I am so embarrassed. Oh my lord. Oh, I stink. Okay, and then we're gonna go with X. X is good. So, yeah. Is this recording? I don't see this recording as moving. Oh, it is. Okay. Give me a second. Okay, so yeah, it's all good. It's all gravy because we haven't hit this one yet. So until we get to this until we get to this X. Sorry. This one's good. This one's good. This one's good. Until we get to this X, then we hit this issue right here. So we are going, oh, this character X is the same as this one right here. So the X that wants to come in is the same as this one that we already have in here. So we're going to take this guy out and we're going to pop it off like that. So when you draw it out, it's quite easy. So bye-bye, popped. And now there's no X because we're not going to put in any of the X's because we don't need them. So that's out. And then we are going to increment. And now we are at Z instead of X. And then we put in Z. And uh-oh, we have a Z here too. So then met this one again. Now we have to pop off this Z on top of the stack. So bye-bye Z. And now we go one more, and we are now at the end of this string, and now we have Y. And we have Y now. Let me actually just, now we're going to pop Y in to the stack. So Y would be here. And then, so yes, we're basically at this part. This is where Y runs. And then we're gonna go, yep, okay, well, that's what it is. And then now we're going to return the stack, which is going to return the successful output, which is this. So that's so the solution does work. Yeah. Wait, so yes. Okay. I have a little question, but I'll figure it out later. Because I'm wondering, like, if it's stack, but then you join it, the output, doesn't it come out as YA? Is it AY? But I think that's why there's the extra space in there. So I think I'm assuming that's probably why. I was questioning that. Anyways, so this solution is both yeah, this solution is good. It's time complexity is O(n) and space, because we are using a stack, is also linear. So this is essentially our runtime in space. So O(n), which isn't really bad, because for such a complicated problem, what I thought was complicated, I thought using a stack, oh my goodness, is so much better than doing it inline, I will say. And that's not even I mean, I've seen some crazy solutions, and I was just like, oh, it's too complicated. It does not need to be this complicated. I think I'm doing it wrong. And I saw this one, and it works really well, and it runs, and yeah, I'm really happy with it. So yeah, so that's it. And that's problem 2, which is remove adjacent duplicates. Okay, cool. Nice. Okay, bye bye. Oh, I'm so glad to be done. I could go to sleep now.